All right, so yesterday we went over 3-1, which was finding solutions by graphing or using tables. And the downside to graphing or using tables is that sometimes we got an in-between value and we are estimating, and it doesn't always come out in an exact fashion. So now we're going to bring algebra into it, and we're going to use our algebraic methods to find our exact solutions. Essential understanding, which you do not have to write down. You can solve a system of equations by writing equivalent systems until the value of one variable is clear. Then substitute to find the value of the other variable. We can use the substitution method to solve a system of equations when it's easy to isolate one variable. After isolating the variable, substitute for that variable in the other equation, then solve for the other variable. So we're going to use substitution when it's easy to use substitution, and we're going to employ other methods when it's easier to do that. But you guys don't have to write down the essential understanding. Just 3-2, solving systems algebraically, and our objective is to solve linear systems algebraically. Okay, so go ahead and write this first problem down. We're going to solve it by substitution. I know that because the title of this problem is solving by substitution. I promised I wouldn't do anything that's way crazy. All right, so I'm going to take this equation because it has a singular y, and I can solve for one variable. So my first item that I'm going to do is solve for one variable. I can use either equation, and I can either solve for x or for y. In this case, I'm going to take this second equation because it's got the singular y, and I'm going to solve it for that singular y. So I start out with 2x plus y equals 10. I'm going to subtract 2 x's from both sides. And I get y equals negative 2x plus 10. First step completed. Solve one of your equations for one of your variables. The second step is the substitution step. So I'm going to take my other equation, and where I see the y, I'm going to put in negative 2x plus 10. So I'm going to substitute, hence the name substitution. So I'm going to take 3x plus 4, and instead of putting in y, I'm going to put in negative 2x plus 10. And that should equal 12 at the end of the day. I guess all right, so all I have to do now is solve for x. I have one equation, one variable. I've known how to do this since pre-algebra in the 7th grade. So we're going to go 3x plus negative 8x plus 40 equals 12. I am going to combine my like terms, so 3x plus negative 8x is going to give me negative 5x plus 40 equals 12. I'm going to subtract 40 from both sides. And I get negative 5x equals 12 minus 40. I believe that is negative 28. Divide both sides by negative 5. And x is equal to, well, 5 goes into 25 5 times. 3 left over, so 5 3/5. All right, so my x value is 5 3/5. So I want to plug that back into one of my original equations and get my y value. I'm going to go ahead and do it to this value here because I could go back to my original up here. I could actually use this one as well, but this one is already solved for y. So I want to work smarter, not harder. So I'm going to go y equals -2. X value is 5 3/2 or 28/5 and plus 10. So this is -56/5 plus, well, 10 is 50/5. Don't you guys love fractions? This is awesome. And so -56/5 plus 50/5 is 6/5, or 1 1/5. So my exact solution to this problem is 5 3/5, comma 1 1/5.
Wait.
All right, so if you're tracking -56/5 plus 50/5 is -6/5. So my answer is 5 3/5, comma -1 1/5. And you guys can graph this on Desmos just to double check that you're in the ballpark. Look at those two equations. Yeah, we're good there. All right, your next example equation is this one here. What is the solution of the system of equations for x plus 3y equals 5 and -2x minus 4y equals -5? I want you to take a moment and think about which one of these equations, number 1 on top or number 2 on the bottom, which one of these equations is going to be easier to solve for one variable. We look at the top equation and it has this x that doesn't have any coefficients. It's going to be the easiest to solve for. So I'm going to go ahead and do that. So my x plus 3y equals 5. I'm going to subtract 3y from both sides. So x is equal to -3y plus 5. I'm going to take my second equation. I'm not going to take my first equation and plug it in because then I will just get a redundant statement. So I'm going to take my second equation, and instead of x, I'm going to put in -3y plus 5. Then I'm going to distribute out that 2. Then I'm going to combine like terms. 6y minus 4y is 2y's. Then I'm going to add 10 to both sides. Double check that all my positives and negatives are in the right place. -5 plus 10 is a positive 5. Okay. And then I'm going to divide by 2 at the end of the day. And I get y equals 5/2, or let me write that as 2.5. Once we find that y is equal to 2.5 or 5/2, we take our original equation, x plus 3y equals 5. Actually, I'm going to take this version of the original equation because it's already solved for x. Let's work smarter, not harder. I'm going to say x is equal to -3 times 2.5 plus 5. Or x is equal to negative 7.5 plus 5. So 6. 6 plus 2.5 is 8.5, sorry. Negative 8.5 plus 5. X is equal to negative 3.5. And let's just double check all of our numbers. So we are going to go back to our original statement here. And this is 7.5. Negative 7.5 plus 5 is a negative 2.5. So x is negative 2.5, y is 2.5. So the solution is negative 2.5, comma 2.5. All right, you guys can have a seat. All right, so we're going to apply this to word problems because at the end of the day, if we don't know how to apply it to word problems, why are we even bothering learning math? Because this is the most similar to real life, and the whole reason is so that when you are in your real life, you can figure things out. So here's a real life kind of problem. An online music company offers 15 downloads for $19.75. So on your paper, you write 15 downloads for $19.75. And 40 downloads for $43.50. So on your paper, you write 40 downloads for $43.50. Each price includes the same one-time registration fee. So on your paper, you write plus a one-time reg fee. What is the cost of each download and the registration fee? You just go ahead and write that whole sentence down with a question mark at the end. All right, so we need to look at how am I going to put this information in a usable format, and then how does this apply to the problem? Okay, so we're going to have two equations. The first equation is going to be 15 downloads, so 15 times the cost of one download, so we have 15 downloads, plus the one-time fee, and that's going to equal $19.75. Then we have the second scenario where we have 40 downloads times the cost of one download plus a one-time fee, and that's going to equal $43.50. If you will give me permission, I want to let T equal the cost of one download. And I would like F to equal our one-time fee. If D is equal to the cost of one download, F is a one-time fee, then my equations become 15D plus F equals 1975, and 40D plus F equals 43.50. In this scenario, does it matter which one I solve for F? No, but preference-wise, I'm going to pick the top one because he has smaller numbers, and I'm more of a simple folk. I like the smaller numbers. And so I'm going to subtract 15D from both sides. So I get F equals negative 15D plus 1975. Then I'm going to plug that into this F in my second equation. So I'm going to get 40D plus negative 15d plus 19.75 equals 4350. Then I'm going to apply the rules of solving equations. I'm going to combine like terms. 40d plus negative 15d gives me 25d's. So these combine together to give me 25d's plus 1975 equals 4350. Then I'm going to subtract 1975 from both sides. Let's do it like this, and then 13, but we need to borrow, so that's 12. This is 15, but we need to borrow, so that's 14, and that's 10. 10 minus 5 is 5, 14 minus 7 is 7, 12 minus 5 is 9 is 3, 30 minus 1 is 20. Oh, that's right, I just went old school, borrowing. Amazing. Thanks for the ride. And then lastly but not least, we're going to divide by 25. $23.75 divided by 375 divided by 25 equals 95 cents. 95 cents. What? Our download fee is 95 cents. So we can go back to our original question. We can say, yeah, download's 95 cents. We're done.
Wait, it asks for the fee too.
Right. So we are not ready for victory dance yet. We need to go back to the original problem and go, oh, it's asking for the download fee as well. We are not done. No victory dance. Stop dancing at home. Okay. So we are going to put in our download fee and find out what our F value is. That's a simple calculator, chug. 0.95 times negative 15 plus 19.75 equals, I got $5.50. All right, so our cost of each download is 95 cents, and the cost of the registration fee is $5.50. All right, we are going to solve using elimination, and what this means is we're going to add our systems together. So what elimination does is it gets rid of one of your variables. So we are going to add our equations together, and it's going to eliminate one variable. We'll solve for the remaining variable, and then we'll plug it back in to find the one we eliminated. Let me show you how that works. If we have 4x plus 2y equals 9, and negative 4x plus 3y equals 16, I'm going to just straight up add these guys together. What is 4x plus negative 4x? 0 x's. 2y plus 3y is 5y. And 9 plus 16 is 25. I am not going to write down the 0x because that just equals 0, and anything plus 0 is just itself. This is 0 property. The addition property of 0. Okay. So to solve for y, I'm going to divide by 5. So now I know y is equal to 5. Yay! So if y is equal to 5, I can plug him into my most simple equation. And solve for my other variable. So in this case, x is equal to negative 1/4. Yay! So my solution is negative 1/4, 5. And my recommendation is, as a new user of Elimination, I would definitely do a graphing check. You can put this in a graphing utility. Check to make sure that you've used Elimination appropriately. And if you haven't, let me know right away so that I can help you guys. All right, second situation here. We are going to go ahead and add these doggone equations right to each other. Negative 2x plus 5x gives me 3x's. 8y minus 8y is 0y's. Negative 8 plus 20 is 12. I divide both sides by 3. I get x equals 4. And I'm going to take the top equation, plug in 4 for x, and we're going to solve for the y. Negative 2 times 4 is negative 8. I'm going to add 8 to both sides so that I'm isolating my y. 8y is equal to 0. Anything that divides 0 is still going to be 0. So my solution is 4, 0. All right, guys, we're going to use this property, the equivalent systems property. Equivalent systems are systems that have the same solution. And you know how I found this? I had my Pearson textbook up. I typed in equivalent systems. I searched in the visual glossary, and it pulled up this definition. So you guys have access to this as well as I do. Any question, anything you want to look up in your textbook, you definitely can. Okay, so if I multiply my system, both sides, by 4, I will get an equivalent system to my original system. If I add 3 to both sides of an equation, I am keeping an equivalent system. So we're going to do a little manipulation. This is why elimination is so evil, because we manipulate and we eliminate. I'm going to do a little manipulation. As long as we're keeping our system equivalent, I'm totally allowed to do this. So I'm going to look at these, at my x and my y. I've got 2x and I've got 3x. If I added those together, it would not eliminate. Now look at my y's. I got 7y and I got 5y. If I added those straight together, it would not eliminate. So what I'm going to do is I'm going to multiply my top equation by 3. And what, just as a guess, what do you think I'm going to multiply my bottom equation by? -2. It is like finding a common denominator. I need my x's to cancel, or my y's to cancel. In this case, I'm aiming for my x's because they have a smaller coefficient. I could do the same process for the y's, but those are bigger numbers, and I want to keep my life a little bit more simple. Okay, so I picked a multiplier. I picked 3 to my top equation because I had a 3x. And I picked 2 because I had a 2x. I put negative because one of them has to be negative in order to eliminate. So when I do the multiplication, I get 6x plus 21y equals 12. Everything left and right gets multiplied. My second equation when I do the multiplication is negative 6x minus 10y equals 10. Now I can do the same process we did for the above problems. I'm going to add them together straight up now that I have an eliminator. So 6x minus 6x is 0. 21y minus 10y is 11y. And 12 plus 10 is 22. Dividing both sides by 11, I get y equals 2, which is only half of my system. I need the other one. So if I know y is equal to 2, I'm going to go 2x plus 7 times 2 equals 4. 7 times 2 is 14, so all I did is I took this and I put in my answer. X plus 14 equals 4. I'm going to subtract both sides, 14. X equals negative 10. Divide both sides by 2. And x is equal to negative 5. Let's put these together so we can have a formal answer. Negative 5, comma 2 is our solution. Since we are new at this process, make sure you are checking. You can use your graphing utility to check your answer. All right, let's see that one more time. We have 3x plus 7y equals 15, and 5x plus 2y equals negative 4. So I could either go 5 and 3 or 7 and 2. What do you guys prefer? It's fielder's choice today. Let's do 7 and 2. So my top one I'm going to multiply by the 2, and my bottom one I'm going to multiply by the 7. Which one do we want to have the negative? Once again, fielder's choice. Top or bottom, which one's going to get the negative? On the bottom, we'll go negative 7. So let's go ahead and do that multiplication. We've got 6x plus 14y equals 30. And we've got negative 35x minus 14y equals 28. X plus 35 plus negative 35x is negative 29 equals 30 plus, this cancels, 30 plus 28 is 58, which, thank goodness, is 2 times 29. Divide both sides by negative 29. Phew! Thank goodness, 58 divided by negative 29 is negative 2. Then we have to find the y, so I'm going to plug in negative 2 into this equation. So it's 5 times negative 2 plus 2y equals negative 4. Does it matter, top or bottom equation? Absolutely not. Doesn't matter. I'll say. Negative 10 plus 2y equals negative 4. Add 10 to both sides. If you guys want to solve equations, we're doing a lot of it. 2y is equal to 6, divide by 2, and the end of the story is y equals 3. Let's put it together so we look like we know what we're doing. The answer is -2, 3. We're going to solve these two systems, and they're going to be weird. I'm going to tell you that right off the bat. Totally going to be weird, but a good learning tool. Okay, so I'm going to use elimination for both. This one I'm going to multiply by 2. So I'm just going to rewrite it down below. -2x plus 2y equals -4. And then I'm going to add these straight up. 2x minus 2x is 0. -2y plus 2y is also 0. 0 minus 4 is -4. Does 0 equal -4? No. 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 So when you get an untrue statement, there is no solution. And in fact, we have 2 parallel lines. 2 parallel lines cross. No. So because parallel lines don't cross, we have no solution. Untrue. No solution. Second scenario, let's multiply by, how about by -3? When I do that, I get -12x minus 3y equals -18. We're going to add these straight up. 12x plus -12x is 0. 3y plus -3y is also 0. And 18 minus 18 is 0. Is 0 equal to 0? If you believe 0 is equal to 0, go ahead and state. Thank goodness we all understand it, because that is true. Yes. 0 is equal to 0 when you get a true statement. There are infinitely many solutions. It is all real numbers. It's the case where our line is right on top of our line. It's the coinciding lines. Okay, after you guys are done writing that down, I am going to give you 2 minutes to write a summary. Please look at your learning objective. Look at all the examples we did together. We talked about elimination and substitution and how to check our answers and what it looks like when we do stuff algebraically and we see no solutions, infinitely many solutions, all real solutions. You've got enough information to put a nice 4-sentence paragraph for your summary. 2 minutes starts now. Mhm.
So you wrote like a 0. There's no 4 4. Could it be a number or something?
Yeah.
Okay, and then put that on each one, so you can just-
Not yet. That's totally different. Okay, so you guys, I'm gonna go ahead and print out the practice on this, and tell you guys can circle which ones I want you to have completed. I can do it from here. And don't let my limitation limit you. If you feel like there is something you need more practice on because 4 examples of elimination wasn't enough and still struggling, go ahead and do more practice. I will not say no to more practice. I will say yes, that's a great idea. That didn't make sense to you the first time, more practice. And then you guys don't have to write this down. I printed out for you. Okay. So 7 through 9, definitely 10. So 7 through 10. Huh? Oh, I'm still recording. Ignore.